We're next going to hand over to our feature focus, which is Lee from the University of Manchester, who will be presenting on towards digital twins of fusion reactors in the metaverse. So very topical. Over to you, please, Lee. We can see your screen.
Okay, thank you very much for the introduction. I'm just going to start my timer. Okay, so this is work that's been carried out in collaboration with the UK Atomic Authority, funded by their Small Business Research Initiative. So it's the output of a very short 6-month evaluation project of a technology called Nvidia Omniverse. So the challenge is to build a fusion reactor, prototype fusion reactor by 2040, and there are various sort of activities that need to be carried out. So there are sort of traditional structural engineering questions. So can the reactor support its own self-weight? And then there's some added complications because inside the reactor is a pressure vessel where the fusion reaction is taking place. And then on the structure, there are also magnetic forces that need to be taken into account because the plasma that's generated by the fusion reaction has to be kept away from the wall of the reactor using very strong magnetic fields. In addition to this, the fusion engineers have this crazy idea that neutrons being given off by the fusion reaction should pass through the reactor and generate new fuel. So so there's an interaction between the neutrons and the materials of the reactor. So this has to be taken into account. And then we've got lots of different control systems, and I've given one example here, which is a control or a system for cooling. And all of this and other systems are all combined to build a reactor. Now, the main challenge of this is that if a designer changes a component in one of the systems, this has a knock-on effect on all of the others. So the ideal situation would be to be able to take a holistic view to design and have a single virtual reactor that the design teams could interact with and build, design the reactor. So this may be possible in about 100 years' time if we have, if we look at science fiction. But how do we do that now? So the idea is that perhaps with exascale computing and artificial intelligence, we may be able to achieve this, but we need a platform to do that. And that brings us to the Nvidia Omniverse, which is a platform developed to improve realism in terms of visualization, to support teams of designers working together as a server that looks after individuals and also assets. And it's been co-designed with Nvidia's graphics hardware and its various software applications to deliver real-time simulation. So in our evaluation of this platform, we had a look at how it might improve collaboration between teams of engineers. So in a typical organization that's geographically dispersed, maybe each engineer or each company involved has their preferred software package, and there is a bit of a conflict in terms of sharing information and making modifications of design to the design. So the Omniverse offers a way around this. So I've got a video to play, and I think I've shared the audio.
In this video, we will talk about design and visualization of the component of a fusion reactor in Omniverse to improve and accelerate the design process. We will be looking at some of the distinct features of Omniverse, which sets it apart from any other design package. These features include multi-user collaboration, one-way and two-way connectors, real-time interaction, photorealistic rendering, and version control. Now let's look at a quick demo. Here we can see three different engineers working on three different components of a reactor in three different packages from three different locations connected via the nucleus using one-way and two-way connectors. Any changes in any of the packages gets updated in real time in the Omniverse without the conventional file sharing and import and export process. We can add or remove components, or we can even edit the existing components. We can also create new components within the Omniverse using the creation tool, and the changes are updated throughout the pipeline. We can add lightning effects for photorealistic rendering using the RTX path traced feature and see how the light behaves from different angles and distances. We can toggle different views and observe the changes clearly.
So I'm going to cut that video short and move to the next slide. So the other thing that we had to look at was how difficult it was or easy it was to integrate scientific software into this platform. And we found it very straightforward, and we used ideas, from the life sciences community, workflows and containerization, and found that we were able to integrate very well. And another example was to have a look at the capability of the software from the point of view of gaining insight from experimental data. So basically, what we have is synthetic plasma data that's been created using simulation tools, and that data is being processed by artificial intelligence algorithms in order to extract diagnostic information from the plasma. So on the top left-hand corner, we've got a real photo of what the plasma looks like in the reactor. And so what the Omniverse offers is the ability to photorealistically render the CAD geometry of a reactor. So this is the CAD geometry of a reactor, and insert inside it the synthetically generated plasma. And the idea with the photorealistic rendering is that the light emitted from the plasma reflects off the internal surface of the fusion reactor. And what we should be able to do is, in a synthetic environment, is create snapshots from a virtual camera looking at the plasma and use that to train our diagnostic tools. To wrap up, I gave a presentation at Nvidia's conference in March, and this has been written up as an article in a online magazine called HPC Wire, where you can find some more information if you're interested. So that brings my presentation to a talk. So thank you for the invitation.
Great, thank you, Lee.